we all love a bit of family. Oh, almost going to sing. Oh, I'm fighting the urge really badly because we are family. No, don't fight it. Fight it. Okay, welcome to Families of Quadratic Polynomial Functions. Wow, you guys are sitting there going, when am I ever going to use this stuff? Yep, couldn't agree more. You're going to use it to get through this year, to go to university and live a fabulously fulfilling life doing all sorts of excitingly interesting things. Those of you who have the pleasure and are being taught by me, please have a go at those questions. They are probably hand-picked the most amazing questions. Not that I'm going to guarantee you a 50 using them, but it'll certainly get you on the way with a little bit of hard work. Those of you in internet world, hello again. Why not subscribe? Subscribe, come on, you know you want to. Loads of videos, and coming soon is a new MaffsGuru website. Fabulous. So, let's do a recap. We've almost reached the work, at the end of the work on quadratics, and by that I mean because I'm following the Cambridge Essentials course with my group, then it sort of makes sense to say, hey guys, almost done. We have so far expanded and collected like terms. We have factorized using the T method, the cross method, the quadratic formula. We've completed the square to give us the turning point form. We have graphed these quadratics. We've solved linear inequalities and quadratic inequalities. We've used the discriminant in more ways than we thought was possible. And we've last time solved simultaneous equations using quadratic and straight lines. Remember, all of this is actually just teaching you tools. You then have to go and apply them to questions, particularly methods 3 and 4, where there are a lot of in-depth questions called extended response, where you have to try and work out which tool to use and how to use the tool. It's important that you practice now. Don't just sort of put it in your head, tick it off, say I've done that, sit at the end of semester test or whatever you're going to do, and then forget it, because I promise you that will make life significantly harder for you. So remember, most of the time we've been given equations. We've been given the values of, if we have the general form of y equals ax squared plus bx plus c, we've generally been given equations like y equals 3x squared minus 4x plus 7, and we've been told to do something with it. We've been told to find out how many solutions there are. We've been told to graph it. We've been told to work out what the discriminant is, blah, 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 blah. Now you're going to do things backwards, where you are going to be given curves with specific information on and asked to come up with the general form of the quadratic equation. So generally speaking, all quadratics come somewhere from y equals x squared. We've already done transformations. We've moved these things around. We know about the axis of symmetry. We know about the turning point. We now need to use that information to help us find. So let's just go for the standard case. So this is the first case. We can see automatically by looking at this, it's a quadratic, and they've been very helpful to give me one piece of information on there, all right? Now, generally speaking, giving me the origin, the point 0, 0, doesn't help anything at all. But where we have the standard form, we can say, well, we know in that situation, the equation, because it's going through the point 0, 0, must have the general form of y equals ax squared. What is the value of a? If you remember, it is a dilation, because we're not suggesting that this is the graph of y equals x squared. If it were, then the value of x equals 2 would have crossed through the value of 4. It blatantly doesn't, so it must be dilated. We need to find the dilation. To be able to do that, we need to be given an x and a y value. How do I get an x and a y value? X and a y. Oh, hold on a moment. That's a coordinate. Yay! As long as they give me one coordinate. So in this situation, I would have said 2 is equal to a times 1 squared. Yay! So 2 is equal to a, and as such, my final equation would be 2x squared. So, having used that one piece of information, I have now found the standard, or the quadratic form of that exact expression. You might be given it in turning point form, and in which case we need to remember that turning point form has that general equation. Y is given by A, which is a dilation, right? B, which is a translation in a horizontal sense, and C, which is a vertical translation. Well, the great thing is, because it's in turning point form, we can automatically see the values of B and C, because we now can say that Y is equal to A, x, well, x minus b, we know that value there is 1, so it must be minus 1, because it's positive 1 here, it's the opposite inside, squared, plus c. Well, that's my vertical translation. That's my y value is plus 3. Okay, well, that one coordinate point there put into the right equation has actually made my life a lot easier again, because all I need to do is find the value of a. To do that, I need one value of x and one value of y. So somewhere else on this graph, there has to be an x and a y value. Well, they've defined one here, but also I could probably use the y-axis intercept if I wanted to, but I don't want to. So I would now say, well, y is equal to 5 is equal to a. We don't know it. X is minus 1 squared plus 3. 5 is equal to a. That's minus 2 squared plus 3. Take away 3 from both sides gives me 2 is equal to a. Minus 2 squared is 4. So in which case a is actually equal to a half. And so formally I could write my equation as y is equal to half x minus 1 all squared plus 3. And it's always important in an exam to make sure that you do write down what it is they're asking you to do. So that's the turning point form. They gave me a turning point. I made sure I used the right equation. Life was good. Intercept form. Well, we know that intercept form looks like this. We've known from all the works we do in quadratics that solving these things helps us enormously if we can solve a quadratic and put it into a linear factor form. And again, these are basically linear factors. Why linear? Because if you look at it, they're basically straight lines. That's weird, but yeah, don't get too deep into that. So again, what information have they given me? They've given me these values here. So I know x equals minus 1 is the solution. So and x equals 1 is the solution. If I go backwards through the null factor law, that would suggest that x plus 1 is equal to 0, or x minus 1 is equal to 0. And that suggests that because using the null factor law, we can then say that, well, we get x plus 1, x minus 1. Oh, hold on a moment. That's remarkably similar there. We need to know whether there is a dilation, and obviously it's got to start with y equals. Well, I've got way too many unknowns. No, I don't. I've only got 3 unknowns. And I can find 2 of those unknowns because I need an x and a y. So they've got to give me another coordinate. And there we are, ladies and gentlemen, 0, minus 2. So I'd have minus 2 is equal to a, x equals 0, which gives me 1. And there's minus 1. So minus 2 is equal to minus a. And so a is equal to 2. Easy peasy lemon squeezy. So my formally last equation would be 2. X plus 1, x minus 1. Now again, you don't necessarily have to go through all of this palaver, because you know that that is minus 1 and that is 1. So I could have written that straight in as my value of b and c. But anyway, intercept form is fabulous. One intercept and at the origin. Now, generally speaking, this is really important, all right? One intercept and at the origin can be written as y equals ax squared plus bx. Now, how does that help? Well, this is actually very similar to intercept form and does use what I did slightly earlier. Think about it. This could also be written as x plus 0 multiplied by ax plus b, right? So that is the point there that's at the intercept. The origin. So we already know that. So what I now know is that ax plus b must also equal 0. Why? Because we use the null factor law. For x plus 0, ax plus b to equal 0, null factor law says that either x plus 0 is equal to 0 or ax plus b is equal to 0. How's that going to help me? Well, ladies and gentlemen, it just so happens that I have an x value. Really? Yes, I have an x value of minus 2. We know that that point there, which helps us use the null factor law, gives me that a times minus 2 plus b is equal to 0. So minus 2a plus b is equal to 0. And, oh, I don't know. That looks a bit complicated. Well, it is, but it's got 2 unknowns. And if there's 2 unknowns, we can solve them if I have 2 equations. But where would I get another equation from? Hold on a moment. This point here looks remarkably sort of lonely. Well, it is, because I need another equation in terms of a and b. How can I do that? Well, I go back to my original equation here. Remember, I've got another equation there that I can use this coordinate. So I know my y value is negative 2. I've got a times x is negative 1 squared. plus b times x, which is negative 1. So minus 2 is equal to a, because minus 1 times minus 1 is minus b. And there we go. I now have, so a minus b is equal to negative 2. And I could go on and actually use my CAS, or in this situation, relatively simple, I could just do by elimination to find my values of a and b. I'll leave that to you to do. But this question here, I've seen on exams all the time, right? So it can also be written in that form. It's just very, very cleverly done. Now, 3 points given. I've seen this year on year on year, okay? Let's just zoom out so I can see my whole graph at this moment in time. There we go. So I've got this function. I've got minus 3.5, 4.5. I've got 1, 0. Actually, that's all the information they need to give me to help me find a quadratic. Remember, the general form of the quadratic is ax squared plus bx plus c. Here, I've got 3 unknowns. I'm going to actually use our CAS to help us find this. So the first thing we do, getting rid of that little bit of red there, is we actually tell the calculator the equation we want to solve. And we're going to say that we remember that rather than writing y equals ax squared plus bx plus c, we're actually going to tell our calculator f of x equals ax squared plus bx plus c. Now the reason being is that coordinates can be expressed in lots of different ways. We are normally happy to write them as 0, 1, 3, 6, 9, 12, and I've just made these coordinates up. But what we're really saying is that this is my x value and this is my y value. But we can also write y as f of x. So what we're saying is that when I put 0 into my function, I'm getting 1 out. So what we're saying is when x is 0, y is 1. That's a different way of writing this coordinate. So 3, 6 can be written as when f is 3, 6 goes in. As x is 3, 6 is coming out. And the f of 9 is equal to 12. So by writing f of x on my calculator, I'm actually going to use that information and the coordinates given to help me. So having done that, all right, that is just me re-explaining. We're going to get our calculator to solve a system of equations. Now, for the Casio ClassPad, there is a button that I think has got something like that in there, that when you press, if you press that twice, you'll get this notation here. And it will be the squiggly lines, and it will have box, 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 line, and box. Now, what it's saying is put 3 equations in there, or 3 pieces of information in there for me. Tell me what you're trying to solve for, and I'll work it out. So, because the coordinates they gave me were 1, 0, minus 2, minus 6, and minus 3.5, 4.5, I've just used the information I did a moment ago to say f1 equals 0, f negative 2 equals negative 6, and f negative 3.5 equals 4.5. And because we are using this equation here, we're trying to find our values of a, b, and c, you have to put here a, b, c. And lo and behold, out comes really quickly and easily a equals 2, b equals 4, and c equals negative 6. So I would then formally state my equation and say, well, therefore, y is equal to 2x squared plus 4x minus 6. Calculator's done all the hard work for you. Now, what's this got to do with anything? Remember, methods 3 and 4 is about applying the learning that you're doing. You're getting a little bit of it in methods 1 and 2, but methods 3 and 4 is really important. So imagine here you've got this question. And again, this has been borrowed from Cambridge Essentials. No infringement of copyright was intended. It's just a great question to use with the teaching of my kids. So assuming that the suspension cable shown in the diagram below forms a parabola. Well, the minute I see parabola, I know that it's talking about a quadratic. Find the rule. Okay, so that means they have to have given me information to be able to find the rule of the quadratic. So we got y is equal to ax squared plus bx plus c. That's one form. What was another one? Y is equal to ax squared if it's a general, or y is equal to ax minus b squared plus c, or y is equal to ax minus b x plus b x plus c. So I've got 4 different equations there. I've got to work out what information they give me in the question. Right, well, do they give me any coordinates? Actually, yes, they do. If you think about it, we can actually say, let this be my 0. Right, and in fact, I'm going to say here, let this be my 0, 0. That's actually going to be my origin. So I now know that this coordinate point here is 0,75. I can find this value here would be 180,75. So there's two pieces of information, but they're not intercepts. I don't have the turning point, although actually, hold on a moment, can I find my turning point? Well, we know for any parabola that there is an axis of symmetry halfway between. So I now know that halfway along is 90, but do I know how high that point is? Hold on a moment, the minimum height of the cable above the roadway is 30 meters, 90,30. So I have 0,75, I have 90,30, and I have 180,75. I have 3 points, so I can either use this define function on my calculator, or I've got my turning point form, either to choose from. I'm not actually going to do the question now, but it's important that you know that with a question, you're trying to find coordinates and then find the form of the equation that you can then use to solve. All right, I think we're done. Thank you very much for being my family for this question or for this little lesson. I look forward to seeing you again sometime soon.
It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right? Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. All right, well, you have an awesome day, and I look forward to seeing you again.